Okay, so in this video, I'm making the case that we need an evolutionary model for thinking about contract design with blockchain. And this is actually what I believe is the central feature that blockchain will bring, and I believe this is the reason it's going to take over in the long run. So if you want to learn good contract design in blockchain, I think you're going to be needing to use evolutionary principles that will ultimately make this anti-fragile. And to think about that, we're going to need some game theory, and I'll have a few videos coming up that involve game theory, and because evolution of course uses game theory. But in this video I'm not going to explain the math of the game theory. What I'm going to do is just sort of make the connections that we should be making when we learn evolutionary models about dogs and bears and birds who are evolving over time. We're going to look at models that biologists have developed in the past, and we're going to apply those models to contract design. We're going to be thinking about genetic engineering that breeders have done in the past to develop dogs and to develop genetically modified organisms for farming, things like that. And we're going to be asking the question, can we apply the same concepts in a world where instead of talking about biological things, we're talking about contracts that facilitate relationships between people. Contracts, for example, on a platform. So let me set up a visual way of thinking about this so that I can explain more easily. Okay, so here's the setup. We're comparing blockchain platforms to, and the way they're going to evolve over time to the evolution of bears, and we're going to think about intentional design of the evolutionary process, or intentional maneuvering of the evolutionary process, which does not mean direct control. It's going to be analogous to a zoo breeder who's trying to breed a line of bears that's really cuddly and could be pets. And I'm using this example for fun, not because I actually think humans should breed bears for pets, but it's a fun example. So what's the analogy? What's the key part of this analogy? And that is going to be that when we're breeding bears, what's changing over time and what's being tweaked, not directly but indirectly, is going to be the genetic code of the bears. And the tweaking of the genetic code in bears is analogous to the tweaking of the contract parameters or contract design in the contracts on the platform. Okay, and what do I mean by contract parameters or contract design? Well, we know that platforms are designed to connect different types of users. And sometimes all of those users sort of have the same role, but sometimes they have different roles. For example, on YouTube, we have content creators being connected with content users or video viewers, and the platform facilitates this relationship between the two. On Amazon, you have buyers and sellers who are connecting through the contracts on the platform, and the contracts make that relationship between those two much more smooth. With Netflix, you have something pretty similar to YouTube content creators and content users, the viewers. It's just that with Netflix, the content creators tend to be bigger players. So platforms tend to create contracts. That's one of the main features they have. They create contracts that connect two sides to a market. And you might imagine each of those contracts has a lot of detail built into it. For example, the simplest thing that might be built in is just what's the price of the Netflix contract. But it's not just the price. It's, are you paying per movie, or are you paying per month? Or are you paying per week or per year? It is, what is the stipulations regarding automatic renewal? It's how many movies you have access to. You might have a certain number of movies accessible for one price and then a greater number of movies for another price, and those numbers are both parameters. It's how many devices can you use your platform on, and how many people's names can you enter. So there's a lot of different parameters, and many of these have numbers associated with the parameters. Some of them, it's less about the number and more about the structure, but these are very complicated relationships, and they involve incentives to keep people coming, disincentives to do things like pirate movies. There's all kinds of things built into this platform, and that's one of the main things these intermediaries, like the big tech monopolies, do, is they get really good at managing these contracts. So you might imagine there's a base contract that everybody's using that's become the common contract. You might imagine on Netflix or on YouTube, and somebody has an idea about what might be a better contract for the users and for the content creators. In which case, is there a way for that to be tested out? And I want to use the analogy here of A/B testing. So we know that big tech monopolies will use A/B testing by randomly assigning a certain page design to some people and a different page design to other people, and seeing which page design leads to more clicks or more user interactions on the platform. And this might be as simple as, is the button red or is the button blue? Where half the people get randomly assigned the red button, half get randomly assigned the blue button. So the company's doing this mini experiment on people, and based on that experiment, it figures out which color works best. That becomes the dominant type of user interface, and then it'll tweak something else. So these platforms are constantly evolving through really semi-scientific experiments in these A/B testing scenarios. So we're going to be thinking about A/B testing contracts and how we might actually make that work. Okay, so let's look at our game theory here. We've got a game theory that I'm not going to explain in this video. I'll explain it in future videos, but basically you have two bears who mate, male and female. Player one is female, the female bear, and the bear can have two types, either a hibernator or a hunter. And the offspring, the number of offspring that the two bears create, will depend on the type of bear that they are. And there's some game theory matrix, payoff matrix here, and there's also going to be a percentage of the population that's hibernators and a percentage that's hunters. So anytime two bears come into contact, they there's a fixed percentage chance, given that whether or not a bear is a hunter or hibernator is not going to determine attraction. We're not doing a sexual selection model here, we're doing a fitness model here. So if 30% of the population is hibernators, 30% is hibernators, 70% is hunters, you can figure out the probability that any bear pairing is hibernator-hibernator, hibernator-hunter, and you can do this to figure out the fitness of the hibernators and the fitness of the hunters. And that's going to help you determine, okay, if we have a mating season between these bears and they have offspring who grow up for next season, let's just say bears have a 1 year time between when they're born and when they're mature and ready to enter the mating population. The question is, what will be the percentage of hibernators and hunters in future seasons? Is it going to grow, or is it going to is the percentage of hibernators going to grow based on the number of children each of these groups have? Will it shrink, or will it be completely stable, where every generation it's exactly 30% hibernators, 70% hunters? And game theory has tools for us thinking about that. And as you might imagine, what this leads to is, if we have a new random genetic variation coming into the system, let's say it's 99% hunters and 1% hibernators, or maybe it's just one new hibernator because it's a new genetic variant that randomly happened in an offspring, we could figure out, is that genetic variation going to take over the population because it has this survival of the fittest advantage, or is that not going to make it to the next generation? So because of that, we can see what kinds of genes will spread and how the population percentages are going to change over time. And this matches a lot of things that are going on with the platforms. I mean, we always talk about things going viral, and That language works really well actually, because viruses, of course, also have a genetic code, also have similar properties as mating bears do when they spread across the population. So the same models that model evolution in a genetic population can also model evolution of things online. And so what we're going to think about here is we're going to think about, there's some standard Netflix contract, and it's got a whole bunch of parameters, just like the bear's genetic code has a whole bunch of genes. And 99% of people get the regular Netflix contract. And however, someone comes up with an idea for an improvement on the contract. And we keep in mind here that with a blockchain board, these people can be held accountable not only by the shareholders, they can also be held accountable primarily by the content creators and the users. So these people are sort of voting on the board, hoping that the board will lead to improvements in the platform for both groups over time. That's how blockchains work. So if someone comes up with a great idea for a slight variation on that contract, maybe there's a different number of movies available for the cheapest plan, maybe it's every 2 weeks rather than every month, they just have some idea about how to tweak that contract. In which case, we can enter this new contract in by allowing people to be guinea pigs, to be randomly tested with a different contract to see if that contract works better for them, or to see if there's any difference for them. And in which case, we need some thing that's analogous to the offspring here. Of course, when we calculate the percentage of bears the next season, we're going to have the number of offspring, the fitness score, as what's going to determine whether it survives till the next generation. We're going to need some analogy over here. And to think about that, since we know, of course, there's lots of human engineering going on over here, we'll think about a human engineering situation with the bears. So let me adjust this to account for selective breeding. So now we have regular bears and bears that happen to be a little bit more cuddly. And this is a new random variation among the bear population in zoos. And so the zoo breeders are like, wow, we'd like a lot more of those cuddly bears. In which case, instead of letting them mate randomly, we're only going to let the cuddly ones mate. Or at least we probably can't only let the cuddly ones mate if there's only a few cuddly ones, because we need to keep the population up. But we're going to give the cuddly bears a huge advantage when it comes to mating. In which case, as zoo breeders, we're modifying the probability that each of these bears makes it to the next generation by actually modifying the payoffs in this matrix. So in which case, the genetic engineers are determining success criteria. They're messing with the payoffs about what will happen with the percentage of cuddly bears the next generation, and they will continue to do this over time so that the cuddly bears will increase as a share of the population. Now, the same thing can be done over here. The trick is we need to know, is this a contract design that's working well for the users and the content creators on the platform? Because, of course, they want the board of directors to make good decisions about the long-run health of this platform and how good it is at sort of getting what they want out of the platform. And that's one nice thing about that is if you just have profit maximizing companies as the board of directors, then they're going to try to maximize engagement. So they're just going to determine, is this a good contract or bad contract based on how many clicks we get and how much ad revenue is generated from these people. These people care about other things other than that. They know that the platform has to operate. We have to pay money for it to operate. So they know that there has to be some sort of financial backing built into the contracts of the platform, but they want to make sure the platform is evolving to better suit their actual needs, which aren't watching a bunch of ads or giving money to advertisers. apart from the need to have ads to keep the platform going. So in any case, we have this normal contract. That's sort of what Netflix has been using, what they've determined works good for now. We have a proposal for a B contract in this A/B testing process, where some people are going to be randomly assigned to a different contract. Now, you might imagine who would be willing to be a guinea pig like that? People don't generally like to be guinea pigs, but you might imagine if you trust the platform and what the platform is doing, if you know that the board of directors is held accountable by content creators and users like you, that it's actually trying to do good in the world because you get a vote in that, you might be willing to be a guinea pig for a short amount of time and undertake a certain amount of risk. So you might be someone who's very risk averse, and maybe you're occasionally, like once every 5 years, you're willing to be one of these guinea pigs, but only if the contract is pretty similar to the contract that everyone's using. Or you might be someone who's willing to take risks. You're okay trying out different contracts that incentivize different things. Because you know that some of those contracts are going to work out and are going to be better than the A contract, better than the original contract. And the blockchain board of directors is going to have to determine what are the criteria for success, for whether or not a particular contract spreads. If 1% of the population gets the random B assignment, which is this new variation of the contract with different parameters, then how do you determine what should be the success? And it might be happiness of users and happiness of content creators. So if they have an 83% satisfaction score with the old type of contract, the AA, then maybe we're only going to continue with the random assignment of B contracts next period if the satisfaction score is over 83. Or maybe, since we know there's random variation, maybe it just needs to be over 50% for us to give it another year to see what happens. But basically, we're going to, if it's successful, if everyone who has the B contract with all of its parameters loves it, like maybe there's a 95% satisfaction rate among this group with the B contract, then we're going to expand the percentage of people entering into the B contract at a faster rate. And that might happen naturally if there's people with different risk levels, where maybe one of the risk levels is you're only willing to take a risk on a new contract if it's already been tested out in a beta test, and most people in that test preferred that contract to their old contract. So in which case, if it performs well, it could naturally expand to more people who are willing to test out the second round and third round of a successful trial of a new contract. So in this case, contracts will expand over time, just like genetic code of successfully bred bears expands over time. So just to reiterate what I've said, success or fitness is one of the ways we talk about that when we use biological models. Fitness in the biological evolutionary sense is number of offspring. Fitness in the platform contract evolutionary system is going to be the number of contracts next period that look like this contract from this period. And if this is being engineered, how do we think about it? So how do people engineer this? They engineer genetic evolution through selective breeding, where the zoo breeders selectively choose which bears get to breed and have children for the next generation. Platform engineering happens with the selection of contract ratios to offer in the A/B testing rounds for next period. And what's the criteria for selecting? Just like the breeders are going to select cuddly bears, we're going to have the board of directors of the blockchain platform select by user satisfaction to decide which contracts will be expanded or contracted next round. So this is just an overview of where we're going in terms of using evolutionary models and genetic game theory models to think about how contract design might be set up to evolve over time. Oh, and one more thing. We might imagine, how do we come up with these genetic variations? Because over here, of course, the parents of the offspring are going to have children who are mostly like them, but they're also going to have a few genetic variations, and that's going to make for nice evolutionary changes over time. Over here, we need something that's analogous to that. So we might have a bunch of people come up with ideas for different ways of designing contracts between the users and the content creators on a platform. And of course, some of those contracts are going to kind of favor the content creators, others of those are going to favor the users. Just like over here, you can have genetic variations that favor the males and the females differently, so there might be a bit of competition in that sense. But how do we decide which of these contracts, if we get 200 suggestions for ways to change the contract, how do we decide which ones we actually try to implement through this A/B testing process? Well, I mean, we could design any mechanism we want for that. We could have people bet on which of these is going to be most successful, and if we don't actually try it out, then they get their money back. But if we try it out, they win some money if that particular contract is more successful, in which case that mechanism could help us determine which of these contracts are most likely to be successful, and therefore which ones should we prioritize when we're deciding which A/B testing contracts to run. Alright, I think that's it. I think that's all I have for framing evolution and blockchain contracts.